Thank you. I'm so excited to be back at Monitorama. It's one of my favorite conferences, and I think I spoke here in like 2016, and so it's like been a little while, and it's just like so nice to see you all again. I'm really happy to be back. Talking about a talk that I also think is fun, so like Pete and I will be at that table by ourselves, and if you want to join us, you can. My name is Emily Nakashima. I am the VP of Engineering at Honeycomb. I might mention some links in this blog post or like things you might want to learn more about afterward. And all of those will be collected up at this URL. There'll be a QR code at the end. And I'll also try to drop the link in Slack. So if you hear about something and you're like, want to know more about that, there will be links if you're not. Different stage companies think about cost differently. So just a little about where I work. Honeycomb is a SaaS observability product for software systems. For today, weirdly, the observability part of it actually doesn't matter very much. Like you can just think of it as a SaaS product. You do need to know that we are building something sort of moderately complex, and we have a reasonably high throughput cloud native software system. But other than that, those are really the big pieces that matter. The more important part for this talk is that we are a Series D startup. We have about 160 people. Our engineering team is about 50 people. We have a highly technical product. We have customers that we like a lot that use that product. And because of what our product is, we have traffic that can be highly variable, but it has some patterns and trends to it that are pretty clear. Everything I'll say about observing costs can be done with a range of observability products, like both paid and open source. So if you have tracing and metrics and you have a way to receive alerts today, you probably have everything you need to do the things I'm going to talk about. Will this talk be cloud vendor neutral? AWS is our preferred cloud provider. We have been there since year one. We know a lot about running on AWS, so there will be some AWS flavored stories in this talk, but I think these principles apply no matter which cloud vendor you use. So hopefully there'll be something for everyone. I'll just say, I know it's day 3. I'm right before lunch. Some of you may be struggling a little bit. Just in case I start to lose you and I start to look like a ham sandwich to you, I'll just share like my most important point up front. So many of our teams work so hard to build proficiency at managing system properties like reliability, like performance. Cost is a system property. It is also correlated or inversely correlated with a lot of these other system properties as they are with each other, so it needs to be balanced. And we should use those same hard-won system skills for cost rather than what a lot of companies do, which is like silo it off as some separate concern that you don't think about very much. The most important skill I think we actually need to do that well is probably observability. So this talk covers things Honeycomb did from sort of seed stage to Series D. If you are a giant company, if someone in your organization is FinOps certified, if you are a founding member of the FinOps Foundation, I am excited for you, and I don't understand you at all. You are very confusing to me. I think your teams can still do a lot of the stuff I'm going to talk about, and you probably have a more sort of structured process for this, and that's great. Like, you do you. This talk is not FinOps certified. This talk will cover 4 cost management scenarios that we live through, not all of which make us look smart and cool. Some do, some don't. And then somewhere in the middle, I will talk a little bit about how to cultivate your inner COO or VP of Finance, basically how to think about costs like your exec team does. So part 1, here we go. Yes, I'm baby, unfortunately. Let's go all the way back to 2019. I know nothing. I've seen an AWS bill before, maybe, but that's it. I am about to become semi-responsible for our AWS bill in that way that like hilariously happens at startups where like nobody tells you you're responsible, but all of a sudden like nobody else seems to be responsible and you're like, oh, like something is wrong and I need to go look at it, right? So I'm about to learn a lot. We did at least do the basics. So I won't talk about these a bunch because these are like, you know, doing your chores, but we did most of these. They are necessary but not sufficient. So we turn things off. Like don't leave expensive, weird stuff running. The like dev environment that someone set up in like US West 2, like go turn it off. Tag everything. Consider your cloud provider cost saving suggestions. It might not seem like they're there to help you, but they are. They really are. Use reserved instances and now savings plan. And then, you know, your cloud provider probably has programs to help you be successful, go faster. Those are good. We were doing all that stuff. We weren't large enough yet to have an enterprise discount plan, which is like a large overall commitment over multiple years for a discount. We did do that as soon as we were eligible, but we weren't big enough. We also were not interesting enough to like work with a cloud cost consultant, which we did down the road as well. And we've never used a dedicated cost management tool and don't intend to, and we'll get to why in a second. So here's where we started. Once every quarter, someone would go, oh, hey, like we haven't thought about the AWS bill in a while. Like maybe we should go look at the console and learn some things about how we're spending money. And that person would sit down and they would put together like a really nice prose narrative about our cloud bill and a nice document with some graphs. And it would be things like, well, write traffic costs 10 times more than read traffic. Or, we spend almost nothing on data storage. It's like retrieving that data for querying that costs a lot. And this like sounds like a bespoke small company approach. But interestingly enough, we still do this to this day. The thing that we learned through this is like engineers actually need like prose about costs way more than they need raw numbers. Like they need those like lines that stick in your head to help them make decisions. We have changed what like the backing data is for that. So sometimes we found that the console was not really enough to understand what was costing what. And we noticed something interesting where we were like, hey, structured logs and traces are like just keys and values, right? You know what else is like just keys and values? That's right, that giant CSV cost and usage report that you can get out of the console. So we fed that into our tracing tool. And now we can sum and break down by tag or instance type. You talked about high cardinality. Guess what's high cardinality? It's tags. And the only real downside to this is like these reports are not real time. Well, it's also a very large CSV. Two downsides. They are mutable and they can sort of take a day or more to finalize. And so we wouldn't do this today because this data is like just a little too laggy for what we're trying to do now. But in the first few years of the company, it was huge to have this information in the same place that engineers looked at every day. We were too small to have those folks who could sort of be the experts, who could like translate what you were seeing in the console to your real world. And if we just put it in our observability tool where we already were, like engineers knew how to self-serve those insights and they could sort of reason about cost by themselves without needing someone to help them. One thing I did learn the hard way, measuring cost can have a cost. Yeah, like calling your cloud provider's APIs can have a cost. And that probably includes some of the endpoints you'll probably hit while like doing cost analysis, especially if you're trying to like automate cost analysis. Nothing makes you feel sillier than accidentally spending a butt ton of money by mistake when you are trying to do cost analysis. So just like keep that in mind if you go on this journey. All right, so luckily at this time, our costs were kind of relatively boring. All of our services are named after dogs. That's a long story. Find me at the happy hour if you want to know. But a really simplified view of our system looks like this. On the left, this is like our data ingest traffic, and we have like relatively high volume, but like also predictable traffic. Like there's very clear patterns throughout the day and the week. Customers send that telemetry data from their systems, and we kind of like know what that's going to look like. That API service sends data to Kafka, which makes it available to our query and storage engine for persisting. And then over here on the right side, we have unpredictable traffic to our web UI, but it's quite small compared to that data ingest traffic. So it was small enough that we didn't really have to think about it a lot from a cost perspective. That service talks to our query engine behind the scenes, so that's how the whole thing kind of like fits together. So we decided it would be cool to build a service that did tail-based sampling for traces. So that's of course going to go in the data ingest path. There she is. Yes, we called the service Dalmatian. And when we were architecting the service, we intentionally wanted to spread sampling operations out across multiple availability zones, which makes sense, right? If we lose one AZ, we still want some telemetry so we can figure out what's going on. And what we really want are whole traces. So we need to have some logic for pushing the right trace IDs in the same place so they sort of cluster together. So let's draw this right to represent that. Great, cool, so we did that. One thing you'll notice if you look carefully is that all of a sudden we're sending a lot of data across availability zones to make sure it lands on the right partition for sampling. So that just increased our costs. And of course, this is a sampling service. So now that we got all that data in the right place, we're going to throw a bunch of it away to perform that sampling. Doing great, doing great. So the DocBill group, who we actually hired later to help us with this problem, made this great chart that explains what happened to us. Yes, this shows how AWS bills for data transfer. And there was one of those arrows that we just didn't think about quite enough. If you spot the arrow, you win a prize. Okay, there's no prize, but try to spot the arrow anyway. And it's easy to do if you have spent 9 hours with the AWS docs or you live inside Corey Quinn's brain, which is not everyone on our team. All right, so we knew about data transfer costs. We just didn't know about them hard enough. What did we learn here? We have a known known. And with cost, known knowns still matter. You can still hurt yourself with them. So we have to make sure our teams read the docs, tag resources, actually use the provided cost tools from our cloud provider, and sort of keep on top of that stuff. I'm going to just pause here for a brief. This is the how to think about costs like an exec. We're really lucky to be able to hire a super talented team of engineers, very high autonomy. They don't just take orders from above. We really want them to go use their own judgment and use that context that they have to go build great things. And one thing that became really clear to us on this journey is that we really have to provide those folks with a lot of context on how to think about cost to do that job well. So some of us are old enough to remember 2021, a long time ago. It's very different now, obviously. Like, woof, it just like feels really different out there. I know a lot of companies have been through layoffs this year. Some people may be job hunting. It's a hard moment. And I think a lot of us are experiencing a little bit of whiplash, right? If you were a venture-backed SaaS, you probably heard the message like, hey, you should grow, spend to grow. And that message started to shift a little bit in 2022. And then like all of a sudden, now in 2023, investors have like really changed their tune. And all of a sudden, like efficiency matters quite a lot. And we're getting this message of like, hey, why weren't you efficient all along? Okay, cool, I'm gonna think about that. So we need to help our teams with this. And we, the observability people, I think are like the best position to help with this problem, especially if it's a little bit newer to your team, to kind of think with this mindset. We're great at doing scarcity. All right, so it was time for cloud cost education. So what do we tell our teams? There's really only 3 costs worth thinking about. For us, it may be different for you, but for us, cloud cost. Sometimes that includes some of the bigger vendor costs, but really cloud cost is the big, the monster slice of it. Salaries, people. We don't try to optimize that one too much. We just sort of think about how much we cost. And then the weird one that we're actually all kind of bad at dealing with is opportunity cost. Harder to think about. We have to remind people, hey, if you spend a day optimizing the cloud bill, that's a day you could have spent building a new feature to differentiate the product or delight our customers. It's obvious when you say it out loud, but it's still really hard to know kind of how to weigh that against other things you would do. I found that it actually comes off way better if you have some non-engineering experts that will come and tell your team that versus from me. So this is Honeycomb VP of Finance, Chris Wozniak, and our COO, Jeff Gray, in their natural habitat, which is a Zoom call that has spreadsheets. And they are great at helping our team understand how to think about that opportunity cost piece and talk them through specific trade-offs and provide examples. Not all finance teams are great at communicating this stuff, and sometimes you just sort of get the message like, hey, don't spend money. And I think if you're in that situation, it is worth going to ask them some specific questions to see if you can get more granular advice. So good conversation starters might be like, hey, how do we weigh the opportunity cost of working to cut spend versus shipping new features? What cash burn rate are we targeting? Like, are we on track? How much are you freaking out right now is also a good shorthand for that. You could also say like, hey, when you look at the engineering budget, what do you worry about? I think the number one thing you'll hear back is surprises. So our engineers know that by now, and when they start to see a change in any of our cost curves, they know to go proactively tell finance, which is a really nice pattern. And then like last but not least, how do I value a discount today against paying up front for like either a longer commitment or putting all the money down right now? And those answers can change relatively quickly as sort of the conditions of your business change. And then we also want to know like what does good look like from their perspective. Generally for our business, we want our COGS, our cost of goods sold, to be correlated with our annual recurring revenue, but growing at a slower rate. So those curves have a relationship, but they're slowly moving apart. Sometimes like naive finance teams will push on you and just sort of say like, don't spend it all, or like make the COGS curve flat. And like, unless you're running like a Ponzi scheme, that's like generally not super realistic. If you have a real product or service with real users who are getting value, that usage is going to grow over time. The thing you really don't want is for the cost curve to become steeper or grow faster when the revenue curve has not changed, right? That's bad. That's when you get the DMs from the finance team. I know this sounds really obvious, but like some engineers don't know that going up is fine as long as the rate is the right rate, right? So it can be useful to visualize it. Our finance team has also been really great about helping us understand industry data to benchmark. So public companies in this space hold earnings calls and they release information about their businesses, and we can use those benchmarks to kind of know what good looks like. So things we could ask are like, how much do companies spend on like engineering, product, and design versus sales and marketing? Or what is their cost of goods sold? What is their margin on the software they're selling? What are their earnings targets? How are those changing? How are they planning to grow over time? And sort of being aware of that stuff, we can build our fluency with what good looks like beyond just the walls of our company. So I started to write this talk and I was like, engineers are bad at valuing their own time. It's like sometimes true, but I think that actually places the fault in the wrong place. Yes, if you make $200,000 a year and you spend all day on a cost optimization that's going to save the company $300, that's a math error. Don't do that. But beyond that, I think people actually need a lot of business context to value their time correctly from one moment to the next. The value of an optimization can change depending on business conditions, and engineers don't usually have an easy way to sort of follow along with those things, right? So what we learned is engineers need a lot of context to correctly make trade-offs in cost. And we want to give our team the simplest heuristics we can to kind of evaluate these things. So tell people, hey, one engineer's time, it's like $1,000 a day. As a startup, remember that our most constrained resource, our most precious resource is time. Money might be second, but time is probably first. And if you think you can win a new customer or build a differentiating feature, it's probably going to be better to do that than to shave away at the cloud bill, unless you can go take a 6 or 7 digit number off that bill somehow. And then finally, cost-cutting investments should have a payback period that makes sense for where we're at. So we probably want to see those payback in under a year, absolutely. Ideally, probably under 6 months. So giving people that time horizon, and it can change, is a useful thing for people to sort of tuck away in the back of their minds. I ran into a really stark example of this whole situation the other day. One of our SREs was feeling good, and he told me, hey, I just signed an all upfront compute commitment, and I saved us 3% per year. And my heart just sank. I was like, oh no. This used to be such a good idea. In 2019, this would have been the hotness. But now we could make more money, leaving that money just sitting in our bank account. And I know that because I am in meetings with our exec team where we talk about our finances and we talk about fun topics like interest rates. He is not in those meetings. How is he supposed to know that? So I need to make sure our whole SRE team who are buying things in the console have the right information. If you're an engineer and you don't have this information, I think it is totally fair to go ask your business stakeholders for it. If you are a manager, track people down who can give you this information and tell it to your team. I think you'll be surprised what people do with it. All right, back to my stories. So story 2, our product uses a custom distributed column store. If you aren't familiar with a column store, here's an example. Don't worry, we don't really store social security numbers, just an example diagram. It's kind of a database, but instead of storing the data in rows, all of the values are stored as columns together, right? So column stores typically deal with sort of wide but sparse rows or events well, and they can perform aggregations on columns of data fairly efficiently. For example, if you wanted to generate a time series from a column timestamp, so that could be quick. A column store, or our column store, which we call Retriever, has this concept of partitions. So, if you are a small customer, you don't need that many partitions. We will just sort of put them on a few, put your data on a few. If you're a medium-sized customer, we're going to spread you out across a few more partitions. And if you are a large customer, you will actually be spread across every single partition in our fleet. You'll be everywhere. When a customer runs a query, all the host partitions that contain their data participate in calculating the result, so they each do a partial calculation against just the data that they have on disk, and then there was some lead that was elected, and that host will aggregate all those partial results together and then return them back via the API. So here's the part that really matters for cost. These instances are really beefy, and they use a lot of compute and memory and storage. And they come in a fixed size fleet because this is stateful, right? So we don't want to auto-scale it up and down. So lots of beefy hosts all together, and they're paired up for redundancy. So this is a relatively expensive part of our infrastructure. So the column data is stored as files on disk on these instances. But we wanted to be able to offer more data retention to customers, and we didn't want to scale this whole expensive beefy fleet up just to do that, right? So we came up with an idea of sort of a tiered storage setup, and we started moving older data to S3 for longer term, lower cost retention. Seems like a good idea. Ian Wilkes, who is the lead engineer on our storage engine, looked at this architecture and said, hey, we just distributed our storage. Do you know what else we could do? Maybe these hosts actually aren't so important anymore. What if we had infinite hosts? So we started fanning these partial calculations out to serverless, to AWS Lambda, and we were sort of able to dramatically parallelize calculations that way, which is really cool because it lets us handle larger amounts of data with sort of similar query times without sort of linearly increasing query time or something. But of course, what's happening behind the scenes? I told you about our boring traffic. That had really shifted a bit since then, so we still had that high volume, predictable data ingest traffic. But our read traffic had actually increased a lot, and it was still unpredictable. So it's interesting, these two variables together. A cool thing about this architecture is that we now have a system that could be a lot less expensive when it's just sitting there idle, right? Like the Lambdas, you don't pay for them when no one's doing stuff with them. And we don't need to make that like fixed size fleet bigger and bigger to kind of handle a certain like peak traffic load, right? But serverless Lambda is typically going to be much more costly per unit of compute than a sort of traditional cloud server setup when you're actively computing. So like, how much does it cost now for us to do this? We have no idea. This is a known unknown for us. And we already had some good techniques for dealing with those kinds of things. So enter observability. All of these Lambda calls were already instrumented with OpenTelemetry, so they appear as spans in our traces. Maybe we can use those spans to calculate cost, right? Yeah, turns out we can. You are billed for your Lambda usage by how long the Lambda runs. And that actually turns out to be the same thing as like the duration of the span you just instrumented. So we can make a calculated field, or if your system doesn't support those, you can actually just add this to your instrumentation directly as a calculation. And that takes the price per second that the serverless compute is going to cost, and it multiplies it by the span duration to get like how many dollars you actually spent to run that Lambda. And then in our metrics tool, our tracing tool, or whatever, we can aggregate those values and sum them up, and then we can like put a dashboard on the wall that says like, hey, we spent this many dollars today running these queries. We break them down into groups by like which sort of source they came from within the UI. And of course, we can also even make alerts on those. So we send ourselves these like low priority alerts when Lambda costs exceed a certain threshold. The threshold differs for different query sources, like SLOs or manual queries. But it's just sort of a way to see how much we're spending. Generally, like, these don't hit on call, but like if a manager sees a bunch of them go by, they'll go make a ticket, and then the team will spend like the next week thinking about cost. So for known unknowns, we want to deal with those with the same tools we already know quite well. Custom instrumentation, some simple alerts, things that we are already doing day to day in our observability practice. All right, third, it takes a map to navigate costs. There have been some great discussions of all the knowns and unknowns in this conference, and I wanted to come back to this like funny category that we don't talk about as much, which is unknown knowns. We talk about these at the individual level, so I as a person have these unknown knowns of like things I don't consciously know, skills I've had for so long that I don't think of anymore, implicit biases, instincts, deeply assimilated knowledge. Unknown knowns can also exist at the organizational level though, right? If something is really well known and obvious in one part of the company, but unknown and needed in another, that is an organizational unknown known. And unknown knowns make the finance team sad. So I've had this exchange a number of times, and I realized I needed to fix it. The finance team says, hey, budgets are tight, but our current cost curve looks good, so we just need to like maintain this for the rest of the year and everything will be okay. That sounds good. Then over in engineering, engineering is planning to ship a butt ton of new features, and every single one of them requires running large batches of queries over lots of data. So these two things are on a collision course, but people don't know it yet. Now it's the time to go make some friends. We ran into this last year when we were working on a query-heavy feature. We wanted to build like a map visualization, and we wanted it to do some querying behind the scenes to sort of aggregate what it was seeing across multiple traces. And we were really worried this feature could be very expensive, like potentially so expensive that we like should not even build it at all. And so we really wanted to like get this right early on. Luckily, we had a plan. Here's the core team that built this feature, and they knew about this cost concern that the business had, and they also wanted to build like reliability and scalability in from the start. And so here's the plan. Yep, that team has an embedded SRE who is Lex. He has a great newsletter, if you know Lex from the internet. From day one, Lex started working with them to help them model all those things and make good choices and balance all those factors together. And so before they were even writing production code, they were already putting together design documents and discussing cost mechanics and making sure that like they really started on day one with that as part of the process. And then as they started to roll this out in the early access program, they measured the traffic relevant to those services to make sure costs for customers of different sizes were acceptable. This is by customer plan type. So we want to make sure that like if we are spending a lot of money, it is for the big customers that pay us a lot of money. That was a good thing to be able to validate with our instrumentation. And it was nice to be able to do that before this was even like out in the world in past beta. So how do we deal with unknown knowns? Of course, we just saw there, what we want to do is get people talking early. For us, that's product engineers and finance and SREs all collaborating together from the start. But I also learned something that really surprised me that I thought was really exciting. We thought that those narratives about cost would be mostly useful to those stakeholders. But what we actually saw is that they are like broadly useful across the whole company. When you can have like a few quippy sentences that summarize how your costs work, this information starts to pop up in places all around the company that you wouldn't expect. Product management, design, sales, customer success. People innovate using this information. They dream up new features that they didn't realize would be viable. They come up with new pricing and packaging ideas that solve problems for our customer that maybe they didn't think we could solve. And they do really cool stuff once you just sort of give them the context. All right, last example. That was cool. We really nailed it with that one. We're feeling really good, but this stuff is cyclical. So we have to learn new lessons, and we have to relearn some old lessons from time to time, unfortunately. Here's a lesson that speaks for itself. We now have a policy to use remote pair programming or screen sharing over Zoom when purchasing reserved instances. One person says, hey, I'm going to purchase this, and the other person looks at it and confirms before they click the buttons. You can guess exactly where that policy came from. And then you can feel a little sad with me, just a little. On the positive side, here's a good one. We had been optimizing for a while. I thought we would never see another big bang optimization again. You know, as you do more and more of this work, generally the optimizations get smaller and smaller. But our field CTO, Liz Fong-Jones, totally proved me wrong. She began experimenting with migrating from x86 chips to Graviton 2. One thing we learned there is like, hey, technology is always moving forward, and sometimes the future is less expensive. So now we've migrated as much of our compute to Graviton as we can, and we've seen improved performance and about 30% lower costs for some of our largest workloads, which is really, really cool. That change didn't take a huge amount of work. You do have to recompile things for the new chips, but that work was, importantly, it was parallelizable and non-blocking, so we could continue to do feature development at the same time. Because we already had good instrumentation on key systems, we could also verify right away that that had actually had the intended cost consequences that we wanted. So just like performance optimization, you think you've done a great one, and you need to go verify in real life because sometimes you didn't actually make something significantly faster in the way that you expect. Cost optimization works the same way. We already had good instrumentation on these systems, which was really helpful, so we could confirm that our quick win was really a win. So here on these graphs, you can see the purple line is for the Graviton chips, the orange line is x86 chips, and you can see those bottom two are P99 and P50, and you see that the Graviton usage is consistently lower, meaning that for those workloads, we probably can actually run fewer instances, which is nice. Even more important than that, you want to ask, like, what does it do for the end user experience? Like, wouldn't it be better to have fewer instances if it was actually slower? Well, we saw that P99 and median latency both improved by about 30%. So that's amazing. Like, we've reduced cost, we have also made the experience better for our users, and we've been able to do both of those things at the same time without a huge amount of work. Big win. But it's a roller coaster. Just when you start to feel smug, I saw this conversation go by in Slack. We tried to test something out. This wasn't even doing real work. We were just going to test something out with CloudTrail, and we misunderstood how it would be built. And we were sort of quietly racking up 5 digits of spend in the background while doing this test. I'm embarrassed, so I put a little fig leaf over the actual dollar amount. I will not tell you how much it was. And we only turned it off because we got lucky and an engineer noticed that there was like this large bucket growing for no reason. So that was not great. We're going to keep working at that. And it's just to say, like, even if you feel like you're building your practice of this, understanding and estimating cloud costs ahead of time can still be quite hard. We are now testing out our cloud provider's cost anomaly alerts to help with this. I'll say, as a company, we are big anomaly detection skeptics, but we actually think it could be useful for alerting on cost versus other system properties. Why is that? With cost, there's no need to make inferences about like the thing that we really want to measure. Like usually we are trying to measure user experience. We're trying to look at all these other signals to do it. In the cost case, we are trying to measure cost, and we can look at cost to do that. So we think it's much easier to actually get useful, actionable alerts. We're trying those out. So now we've filled in the whole quadrant. We've got those unknown unknowns. For those, we want to instrument all the things, and we really want to use our observability practices that we've also are already built. And then maybe we can have a little anomaly detection too as a treat. All right, what did we learn? Cost is just one more system property. We know about managing system properties. There are benefits to using the observability tools that engineers already know how to use and look at every day. Business context is essential for engineers to make the right cost choices. And if we make friends with the finance team, the whole company might benefit and be able to innovate more. And last but not least, we want to start by considering cost before that first line of code is written, just like we do for reliability and scalability. All right, like I said, if you want these slides or if you want longer prose descriptions of some of those projects, those are all at that URL, or you can scan the QR code. I'll also try to drop the URL in Slack. Find me if you want to talk about this stuff. I always love talking about it. And thank you so much for listening.
Fantastic. Emily's such a pro that the timer is literally at 1 second. That is how polished this is. We've got a couple of minutes, though, for questions, though, before we break. Any questions from the audience? Any finance people? Oh, I see. There's two. So we'll do the slightly that way person.
You've got actionable cost alerts. Who gets them, and what do they usually do?
Who gets the actionable cost alerts, and what do they do?
Ooh, that's a good question. We have a Slack channel that's for like real stuff is going down in production, and they don't go there. We have a Slack channel that is called Signals. That is just like stuff we're sort of keeping an eye on to build our spidey senses. I will say the process for translating from signals to ticket to work done is not perfect, but enough people look at that if we've seen the same thing go by a couple times, someone will like make a ticket and then it will become like medium priority, but not like everything's on fire priority.
Great question. In the back.
So you showed the using land iterations for that calculation. What about, do you have any longer running like EC2 type stuff that you monitor as well? How do you track those costs? Is it just cost report directly, or do you have any tracing tie-ins?
Yeah, how do you track the more, I guess, generic EC2 costs?
Yeah, that's a good question. We use a couple different methods for that kind of stuff. Some of it we can instrument, and then when we sort of like build graphs that we share with our team, a nice thing you can do is sort of describe how to jump from some of the more like system-oriented metrics to cost. Like realistically for us, a lot of those are sort of not our most interesting or surprising costs, and so there hasn't been as much focus on instrumenting those well. But a lot of times it's a similar sort of inference where you sort of say like, how can I most approximate like what this would be and sort of send it out to people. We don't do it trying to use like a span or duration or something like that because those are running for a long time. But we will sort of find other ways to be able to like count them up and then show something in the UI that is like meaningful from a cost perspective. It's much more about labeling versus instrumentation.
Awesome, great. Any other questions? Anything from the top? All right. Well, let's give another big round of applause for Emily.